much time does your job search take? 3-4 months?
Hello everyone, am I audible? Okay, fine. So today in this session, we are going to discuss the MCQs on process scheduling in operating system. So this is our question of the day question. Okay, so here they are given 5 processes at their corresponding burst time. Then they are asking the average waiting time. So we will discuss the answer for this question at the end of the session. Stay tuned. So now we move to the mock test part. So the question is, which of the following is false regarding the first come first serve? Options are FCFS performance is high, average wait time is high, its implementation is based on FIFO queue, then FCFS is easy to understand and implement. So which is the right answer? So give your answers. So what is the answer for the first question? So the right answer for the first question is, it is option A, FCFS performance is high. So that is the false one. Then the second question, in round robin scheduling, each process is provided the fixed time to execute. It is called batch time, job time, quantum, then period. So the right answer for the second question, it is quantum. Then the third question, task is used to save the states of preempted processors. Options are context switching, quantum, process period, and batch jobs. So these are the direct questions only. So I hope there is no need to give the explanation for these questions. So dash is used to save the states of the preempted processors. So the answer is, it is context switching. Then the fourth question, what type of scheduling is round robin scheduling? Options are linear data scheduling, non-linear data scheduling, preemptive scheduling, then non-preemptive scheduling. So what is the answer for the fourth one? Yes, it is preemptive scheduling. Then the fifth one, the OS maintains the PCBs in process scheduling queues, job queue, ready queue and device queue. The OS maintain all PCBs in process scheduling queues, job queue, ready queue and device queues. So PCB means it is the process control block. So this is the data structure used by the OS to store all the information about the process. So the right answer is process scheduling queues. Then the sixth one, when the suspended process is moved to the secondary storage, this process is called, options are process mix, swapping, swap in, swap out. So the right answer for this question is, it is swapping. Then the seventh one, which scheduler speed is fast? Long-term scheduler, short-term scheduler, medium-term scheduler, then swapping. Which scheduler speed is fastest? So the right answer is, it is short-term scheduler. Then the eighth one, a dash is the mechanism to store and restore the state. Options are PCB, program counter, scheduling information, then context switch. So the right answer for the 8th question is it is context switch. Then the 9th question, the processes that are residing in main memory and are ready and waiting to execute or kept on the list is called job queue, ready queue, execution queue, then process queue. So the right answer is it is ready queue. Then the 10th one, in priority scheduling algorithm, when the process arrives at the ready queue, its priority is compared with the priority of options are all process, currently running process, parent process, init process. So what is the answer for the 10th one? Very good, it is option B, currently running process. So this is the question of the day question. The following table is given. So there are 5 processors P1, P2, P3, P4 and P5. Then the burst time also given 10, 29, 3, 7, 12. Then they are asking the average waiting time. So 28 milliseconds for FCFS, 30 milliseconds for shortest job first, then 23 milliseconds for round robin. Then the time quantum is 10 milliseconds. So first we are taking the first option. So the first option is first come first serve. Okay. First come first serve. So we put the Gantt chart. So here they didn't mention the arrival time. So we assume that all the process arrive at time 0. Okay, so first P1. So the burst time for P1 is it is 10. So here 10. Then the second process P2. So 10 to 29. So this one become 39. Then the next process P3 it is 3. So which means this one is 42. Then P4. So the burst time value is 7. So 42 plus 7 it is 49. Then P5 it is 12. Okay, so the value is 61. So this is first come first serve. So it is very easiest one. Okay. So now, so we are calculating the waiting time because they are asking the average waiting time only. So waiting time is the total time spent by the process in the ready state waiting for the CPU. Okay. So the waiting time for P1 is 0. Then P2 is it is 10. Then P3 is it is 39. Then P4 is it is 42. Then P5 is it is 49. So sum all the values. Okay. So 10, 39, 49, 49 plus 42, it is 91. So 91, 100, 140. So they are asking the average waiting time only. So 140 by the number of processes are 5. So this one is 28 milliseconds. So the first option is correct. But we have to check other 3 options too. Okay. So we are taking the next one. So that one is the shortest job first. So shortest job first. Again we are putting the Gantt chart. So first, which one is, so which process burst time is very least? It is P3. So first P3, then P4, then P1, then P5, then P2. So the sequence is P3, P4, P1, P5, then P2. Okay, now we are going to put the Gantt chart. So first one is P3. So the burst time for P3 is 3. So here 3. Then P4. So the burst time for P4 is 7. Okay. Then the next one is P1. The burst time for P1 is, it is 10. It is 20. Then the next one is P5. So the burst time is 12. So which means this one is 12, 20 plus 12, 32. So the next one is P2. So P2's burst time is, it is 29. So which means this one 61. So again we calculate the waiting time for each process. So the waiting time for P1 is, it is 10. Then P2 is, it is 32. Then P3 is 0. Then P4 is 3. Then P5 is 20. So again sum up all the values. So 42, 45. So 45 plus 20, it is 65. So 65 by, so the total number of processors are 5. So this is 13. So 13 milliseconds. So the second option too correct. So we have to check the other option, round robin also. Okay. So here they are given the quantum value for round robin. So again we put the Gantt chart. So the first process is, it is P1. Okay. So the time quantum value is, it is 10 only. So P1 occupies 10 milliseconds. Okay. So P1 is completed. Then P2. So other 10 minutes. So remaining is 19. Then P3, it is 3 only. So 23. Then P4, it is 7. So 30. Then P5. Okay. So P5. So 10 means it is 40. Remaining here 2. So then again remaining we are having 2 processes only, P2 and P5. Okay. So first we give P2. So this one becomes 50. So remaining 9 here. Next P5. So this is 2 only. So 52. Then finally we are having only one process. So that is P2. So 52 plus 9, it is 61. Okay. So again we are calculating the waiting time for each process. So P1, so the waiting time is 0 only. So that is no problem. Then P3, so the waiting time is, it is 20. Okay. Then the waiting time for P4 is, it is 23. Here also no problem. So we are having two processes, P2 and P5. So we are doing the preemption here. Okay. So which means we have to calculate the waiting time for these two processes using the formula. So the formula is last start time minus arrival time minus preemption into quantum. So this is the formula. So last start time for P2 is, it is 52 here. So arrival time we assume that 0. Okay. Then the preemption, the number of preemption happened. So for P2, 2 preemptions. So in this place 1 preemption. Okay. Then so here 1 preemption, then here 1 preemption. So which means context switching happened in these two places. Okay, so the number of preemptions is 2. Then the time quantum value is 10. So 52 minus 20, it is 32. So the waiting time for P2 is 32. So using the same formula, we have to calculate the waiting time for process P5. Okay, so the last start time for P5 is, it is 50. Okay, then we assume the start time, arrival time is 0. Then the number of preemption. So only 1 preemption here. Okay, so 1 star, the time quantum value is 10. So 50 minus 10, it is 40. Okay, so the waiting time for P5 is 40. So again add all the values, it is 43, 45, 75, then 115. So 115 by 5, it is 23 milliseconds. Okay, the third option also correct. So which means the right option for this question is all of this. So I hope everyone clear with this concept. If you are new to this channel, kindly subscribe the channel. If you people find our videos interesting and informative, kindly provide your support through likes, comments and sharing the session links with your friends and college groups. And also provide your valuable feedback on today's session in the chat. So every day we are having the mock test at 9:30 p.m. So attend the test without fail. So thank you all. We'll meet you all tomorrow.